Hello, in this video we start working with quadratic functions. This is done in chapter 20 in your book. We are going to look at the opening problem. So you should now stop the video and make sure that you read it carefully. Okay, I hope you understand the situation. So the tennis player is tossing the ball before he is going to hit it with the racket. So we have a function h that tells us t seconds after tossing the ball, what is the height in meters of the ball? We have 3 questions to answer, and I think the first one is straightforward, so we can answer it without much help. It's asking us how high is the ball when it is released. So when it is released, that will be the time t equals 0. So we want to know what is the value of the function h when t is equal to 0. So we need to substitute 0 by the value of t, and we're going to get that this is negative 5 times 0 squared plus 6 times 0 plus 2. So that means the first two terms are 0, so the answer is 2 meters. So the ball was 2 meters when it was first released. Now we have to answer 2 more questions that are a little bit harder to answer if we don't know how this function looks like. So what we're going to do is to move to GeoGebra. We're going to sketch a function in GeoGebra, and we're going to try to answer the two questions that we have left. I open a window for GeoGebra Classic 5. I recommend that you install this version in your computer if you haven't done it so. And I'm going to type the function h of t is given by negative 5t squared plus 6t plus 2. So that's my function. An important point on this function is the one that we already found, the point 0, 2. That's the y-intercept. So it's the value of the function when it's crossing the y-axis is 2. That was the value corresponding to t equals 0. We could zoom in a little bit to have a better view of the function. Okay. And actually, I only care about the function for positive values of t are, well, greater or equal than 0. So let me add that condition to the function. I double click and I add t greater or equal than 0. So that's the function we are looking at. The second question we want to answer is what is the maximum height that the function reaches. So what is the maximum height that the ball is going to reach? And we don't have the tools to find exactly what the maximum height is, but there's this point over here that's, well, around that point over here that I'm going to click. Yeah, point B, it says it's 0.6 for the t coordinate and 3.8 for the y coordinate or h coordinate if you want to call it. I don't know if I'm clicking exactly at the most precise point, so I'm going to answer that the maximum height is approximately 3.8 meters, and later on we're going to have the tools to answer what is exactly the maximum height. But for now, this is the approximation we get from the picture. So I'm going to write it over here. The maximum height is approximately 3.8 meters. And as I promised, later we'll know that this is exactly the maximum height. Now let's go to the last part of the question. It says that Bradley hits a ball when it is 3 meters above the ground on its way down. And we want to know how long after he releases the ball he hits it. So let me add over here the picture of our tennis player. So he is tossing the ball, and then when the ball is 3 meters above the ground, he's gonna hit it. He's ready to hit it, and it says 3 meters above the ground. So I'm going to find when this function has the y coordinate 3. So I'm going to consider the horizontal line y equals 3. And I see that there are 2 points on that line that are at the same time in our graph. So I'm going to mark those 2 points, the point C and the point D. So after 0.2 seconds, the height is going to be 3, and then again after 1 second, the height is going to be 3 as well. And because the question says that he's going to hit the ball when it's going down, then the answer is going to be that we're talking about the point D. So it means that the time in seconds is 1 second. So let's answer it over here. And this was our opening problem. Our goal now is to learn more about quadratic functions and their graphs. And we're going to be able to answer many questions like the ones we did over here, even without using GeoGebra.